Assalamu alaikum. I am Dr. Saeed Ali Mardan Nazmi. Welcome to my channel. In this lecture, we will learn how we can evaluate iterated taper integrals. For this purpose, we will learn exercise 15.5, question number 16 from Thomas Calculus 12th edition book. Before start solving this question, first of all, we must know some basic terminology about triple integrals. And these are, in triple integrals, we have three kinds of variable, and we have to perform integration with respect to each variable. Here, you can see in this integral, we have the limit 0 to 1, 0 to 1 minus x squared, 3 to 4 minus x squared minus y. We have to integrate x, and then you can see here dz, dy, dx. So how they are related to each other. This dz or this variable z is called most inner variable. And the limits of z are 3 to 4 minus x squared minus y. Then the variable in the center is called center variable, whose limits are 0 to 1 minus x squared. Then we have the variable which is written in the most outer side is called outer variable, and its limits are 0 to 1. In multivariable calculus, whenever you are going to solve a triple integral, you will always start your process of integration with respect to most inner variable, and then on the outcomes of integration of inner variables, you will apply rules of integration with respect to center variable. And then on the outcomes of integration with respect to central variable, you will apply integration or rules of integration with respect to outer variables. So this is an iterative process. First of all, performing the integration with respect to inner, then central, and then most outer variable. So we will follow this order always, inner to outer, inner to outer. Now, one more important thing, in multivariable calculus, whether you are doing partial derivatives or multiple integrals, when you are working with respect to one variable, other variables will behave like constants. So if I have to integrate x with respect to z, this x is constant and we will integrate dz. So the first step is x into z for the limit 3 to 4 minus x squared minus y. Then in the next step, I will apply fundamental theorem of calculus, upper limit minus lower limit, making the simplifications. This 4 minus 3 is 1, minus x squared minus y. In the next step, I will multiply each term with x. And up till here, we have completed the process of integration with respect to z. In the next step, I will perform integration with respect to y. Please note that with respect to y, x will be constant. So x minus x cube will behave like constant. And we will perform the integration. Integration of x will be xy. Integration of minus x cube is minus x cube y. And integration of minus xy is minus x into y square over 2 for the limit 0 to 1 minus x square. In the next step, we will apply fundamental theorem of calculus, upper limit minus lower limit. Here it is. For upper limit, I have replaced y with 1 minus x square in each term. And for lower limit, I have replaced y with 0 in each term. So upper limit minus lower limit is the application of fundamental theorem of calculus. You can see in the second bracket, if you multiply each term with 0, it becomes 0. So all the terms in the second bracket become 0. And we are left with only one bracket, which is the first bracket. Now, in the next step, I will start the process of simplification. You can see in each term, you have 1 minus x squared common. In the first term, in the second term, and in the third term. So you can take 1 minus x squared common. So from the first term, we have x. From the second term, I have x cubed. And from the third term, when I take 1 minus x squared common, I am left with only power 1. In the next step, I will open up the bracket. and then divide each term with 2. So x into 1 is x into x square is minus x cube, and now opening up the bracket here, minus x over 2 plus minus minus plus, it become x cube over 2. Now here x minus x over 2 become x over 2, and minus x cube plus x cube over 2 become plus x cube over 2. Sorry, minus x cube over 2. So from here we can take 1 by 2 common, and from denominator, and from the numerator we can take x common. So when I take 1 by 2 common from this second bracket, we can take it outside, and if I take x common, I can write it here. So I am left with 1 minus x square in the second bracket. Now 1 minus x square and 1 minus x square become 1 minus x square whole square into x. So up till this step, we have completed the process of integration with respect to central variable, and we have completed the process of simplification. In the next step, we will perform integration with respect to x. But before doing that, we need to revise this formula, and the formula is f of x raised to power n into f dash of x dx is equal to f of x raised to power n plus 1 over n plus 1 plus c. Means if in the process of integration you have a function with some power and derivative of that function is available as a multiplier, then in the process of integration we will add 1 in the power of the function, and then we divide with the same term. So in the next step, I am going to apply this formula here. In order to apply this formula, 1 minus x squared whole power 2 into x, we need the derivative of 1 minus x squared. The derivative of 1 minus x squared with respect to x is minus 2x. So there is a deficiency of minus 2 here, and we can cover this deficiency by multiplying with minus 2 and dividing it with minus 2. In the next step, I have done it. You can see here I have multiplied with minus 2, and now to balance it, I have divided minus 2. Now I can apply this formula here. So the integration of this whole function is 1 minus x squared raised to power 3 over 3. In the next step, in the denominator, 4 and 3 will be multiplied and become minus 1 over 12. And we can apply limits in the numerator, upper limit minus lower limit. When we apply the limit, we get 0 minus 1. Then minus 1 over 12 into minus 1 become plus 1 over 12. I hope you have understand this question. Thank you so much for watching this video. Please like, subscribe and share this content with your fellows. Allah Hafiz.